So, yeah, XY coordinates. We got a mass here, one here, and one here. What's the mass of this one?
200.
This one?
100, and then 300.
And what's this length?
10 centimeters and 10 centimeters.
Okay. And it's looking for the center of mass.
Right. And so what I did is I took, for the X, I set my 0, well, they give us a set 0.
Uh-huh.
So I did 0 times 200
Okay.
plus 100 times 10 plus 300 times 10.
So, bad marker. X of your center of mass is going to be 100 times 10 plus 300 times 10 plus 200 times 0.
All divided by 600.
Okay, so that's your mass times the distance from the 0 in X for each of them, then divided by the total mass. So what is that? 100 times 10 is 1,000 plus 3,000 divided by 600, so 4,000 divided by 600. Should be 66.66666666.
4,000 divided by 600.
Yeah.
Yep.
Or 6.666. So 6.67 centimeters. So that'll be right about here.
And then for Y, I had 200 times 0 plus 100 times 0 plus 300 times 10. Does that make sense?
Yep.
Okay, cool.
So the reason that those don't contribute any mass is because they're right on your center line. Then you divide that all by 600. So it's 3,000 divided by 600, which is 5.
Yep.
So if you were to try to if you were trying to balance this based on the y-axis, would it make sense that you'd balance it right through the middle?
No.
Why not? Just the y-axis. We're not worried about x right now.
Oh, yes.
Yeah, because you have 300 grams on this side, right? 300 grams on that side, and they're equal distance apart.
Oh, that makes sense, yeah.
And then for x, you have 200 grams here and 400 grams over here. So you'd have to balance it closer to the 400 gram side. So then if you want to find your center of mass, you just take those two coordinates and be right there. So those are the coordinates for your center of mass, 6.675.
Cool.